So now we are going to determine the bearing of T from R. T from R. So we need enough pole at R to begin to draw the curve to stop on the line that joining T from R. So we have to draw enough pole. It's an arrow going upwards towards the north, straight up. We have some space there. Can we bring this down a little bit? Right. So we're going to draw the north pole and then the curve. Oh, we have a curve there already. I can use that curve. I can use this curve. They just copy and paste that curve there. And color code it so it can look differently. Where's the curve I want? Not 148. That's 148 right there. From the North Pole and stopping at R. And we can color code it. And let me just set it up nicely. So this is the angle we would like. This is the bearing. An angle, a bearing is an angle from the north line in a clockwise direction. So this is the angle, this is the bearing of T from R. That's what we're trying to find. Now I had to bring forward some theorems so that we can solve this problem. Remember, these are two north poles so that they are parallel to each other. Okay, let me put an N to show that this is a north pole. And R, capital N for north. Okay, so two north poles are parallel to each other and you've got a line LR transversing them. Okay, cutting across there. So you have what you call a theorem called co-interior angles. They are supplementary, they add up to 180 degrees. Co-interior angles in parallel lines occur in between two parallel lines when they are intersected by a transversal. The two angles that occur in the same side of the transversal add up to 180 degrees. So that's 65, and this angle there adds up to 180 degrees. So we can subtract 65 from 180 to get this angle. Please take note of that. So this angle there is 115 degrees. What we're missing to find now is this little angle inside there. Now we can use the sine rule because we have a side and an opposite angle. 269.156 is opposite to 83, and 180 is opposite to that angle there. So we can use the sine rule to find this angle there, the angle LRT. Now the idea is now when we find X, we're going to add it to 115 and we're going to subtract from 360, and then that will give us the bearing of T from R. So we're going to add X and 115, subtract it from 360, then that will give us the bearing of T from R. So let's use the sine rule to find X. We know the triangle is already an oblique triangle because we are dealing with the same triangle. Now, we know that 180 or X, it's always good to start with the letter you're trying to find. X is opposite to 180. and 283 is opposite to 269. So the mere fact we mentioned opposite twice, then we've got to use the sine rule. A over sine A is equal to B over sine B. And let's substitute. Remember, the lowercase letters are the sides and the uppercase letters are the angle. So therefore now, what do we have? We have 180 is 180 over sine x is equal to 269.156 over sine 83. Now we've got to cross multiply. 1 sine x times 269.156 is equal to 180 times sine 180 times sine 83. And now we have cross multiplied, so let us divide. We have to divide by 269.156 to cancel it out, because bear in mind it's x we are trying to find. So we are applying cross multiplication and division. 180 times sine 83, or 269.156 times sine x, is equal to 180 times sine 83, and then we are going to divide to cancel out 269.156. Cross multiplication and division must be applied when you are using the sine rule, because you are dealing with two fractions equal to each other, or two ratios equal to each other. You must cross multiply and divide. Now let's find what is sine 83. And to find 180 times sine 83 over 269.156. Sine 83 is 0.968. So we can just type in our calculator 180 times 0.968 divided by 269.156. We must get a decimal. So this is 0.647. Now to find x now, we have to inverse sine. Okay? That's how we cancel out sine, by finding the inverse of sine. To find x, x is equal to sine inverse of 0.647. The online calculator on math is fun. So we find the inverse sine of 0. That's how much? 0.647. And that's 40.32. So the bearing of T from R is the 360. Remember, an entire circle is 360. Subtract the 115 and the 40.32. And that will give us a bearing of 204.68 degrees.